All right, so I mentioned in the last video that there's something called the quotient rule, right? And if you've read the section, then you've already seen this, but we have learned how to take derivatives of products. Now let's learn how to do a derivative of a quotient. I'm not going to provide a proof for this one. I'm just going to kind of give you the rule, and then we'll practice using it here. So a quotient means a fraction, right, or division, so f over g. And the rule is it's f prime times g minus, this time instead of plus, f times g prime, and then all over g squared. Now the order of that subtraction in the numerator does matter, so make sure that you are doing the derivative of the first function first, the first one being the numerator. Okay, so actually sometimes I've heard this as low d high minus high. This is terrible. It's low times the derivative of high minus high times the derivative of low all over low squared. So this is if you've got high and low as numerator and denominator, and it's kind of rolls off the tongue. You can sing it like low d high minus high d low all over low squared or something. So let's do an example. Let's do the derivative of the same function we did on the previous page, or the previous video, e to the x over x squared. So here we have our f and our g, right? F is e to the x, g is x squared, and now we can do f prime is still e to the x, and g prime is 2x. But now putting these into the quotient rule, we're going to have the derivative of our f, so which that's e to the x, times the original g, which is x squared, and then now minus original f times the derivative of g, 2x, and then all over g squared, which is x squared and then squared again. And so that should be our derivative. Now that doesn't look anything like the answer we got in the last video. Let's look what was our answer in the last video. Here's number 3. We got this, right? We got e to the x times 1 over x squared minus 2 over x cubed. Huh. Well, that looks different. But let's do a little bit of algebra on it. Let's factor out an e to the x, since it's appearing in both terms in the numerator. We can pull it out. That'll give us x squared minus 2x, and then that denominator is x to the power 4, right? Can't we just distribute the division by that denominator? Oh, hey, I think if we simplify this, x squared over x to the power 4 is 1 over x squared, and then if we cancel an x here, we get 2 over x cubed. Hey, that is actually exactly the same as the answer we got last time. So don't worry if your answer looks a little different. It might be that by some sequence of algebraic steps you can get back to the same thing. This means that if you're, for example, comparing your answers with a classmate and you have different answers, it might be that you just approach the problem in different ways and use different differentiation rules. Your answers should, though, still be equivalent to each other if you both did it correctly. And I will take any correct answer for full credit. Yeah, I think that's about that.